Okay, so we are here as our first video, part 4, chapter 15b. Okay, and first we need to kind of think about, go back to part 2, what happens when we shift our data by adding a constant. Okay, so remember we want to talk about adding a number to each piece of our data. What changes there? Okay, so when we add a constant, that is when we shift all the measures of our location. So we shift the measures of location only. Okay, so remember that's our median, that's our mean, our Q1, our Q3. Okay, whenever we add a constant to all of our pieces of data, all those change, but our measures are spread, our standard deviation, and our IQR, those stay the same. Okay, and now think about when we rescale our data, so we multiply by a scalar, multiply by a value, what does that change? Well, that shifts our measures of location and all of our measures of spread. So shifts our measures of location and spread. Okay, so when we multiply all of our pieces of data by a scalar, it's going to change everything, our spread and all of our location spots. Okay, now let's talk about our variance. So variance is our expected value of the square deviations from our mean. Okay, so again, it's our expected value of the square deviations from the mean. From the mean. Okay, so we're going to kind of go between standard deviations and variance today. And one thing that we need to know is that our variance of our random variable x is equal to our standard deviation squared of x. Okay, it's just our standard deviations squared. Alright, I want you guys go ahead, pause the video, pull out your concept chart. Okay, so we're going to be looking at shifting and rescaling random variables. So our mean, so whenever we are going to shift our random variable, so if we have a constant a plus b for our mean, alright, that's going to be equal to our scalar being multiplied times our expected value plus our constant. Okay, and our standard deviation of ax plus b is going to be equal to a, the scalar, times our standard deviation of our random variable. Remember, we're not going to add the constant to our measures of spread. Okay, and so now for when we combine random variables, so let's say that we had two different random variables, so we have our expected variance of our random variable x plus our random variable y. Well, that's going to be equal to our expected variances, our expected, our expected value of x plus our expected value of y. And it would also be the same thing if we were subtracting, so I'm going to put plus or minus for each of them. If we're going to subtract two random variables, then we're going to subtract the expected values of those two variables as well. Okay, and now when we talk about our variance and our standard deviation, so our standard deviation of x, our random variable x, plus or minus our random variable y, well, that's just going to be equal to the square root of our standard deviation squared of our random variable, and it's always going to be, you have to remember this, plus our standard deviation squared of our random variable y. Okay, big thing, big concept, big part in there is that you need to know that when it's, no matter if we're adding or subtracting the standard deviations, we always add the standard deviations under the square root symbol. Alright, so I want to go ahead and I want to skip to example 2 first. Alright, so we're given two random variables, a random variable x and y, and we're given the means and standard deviations. And for A, it's asking us for x minus 40. Okay, and we want to find the standard and the standard deviation and the mean of these variables. So now, remember, we're subtracting a constant, so our expected value is going to be of x minus 40. Well, that's just our expected value. So our mean of 70 minus 40. So that just gives us a 30. I forgot the 40 up there. Okay, and then our standard deviation, all right, of our random variable x minus 40 is going to be equal to 11, because remember, whenever we add or subtract a constant, it does not change. The standard deviation does not change our measure of the spread. All right, now for part B, we're looking for 3x plus 25. So our expected value of 3x plus 25 is going to be equal to, well, we have a scalar, so we have to multiply that. So 3 times our mean, which was 7, plus 25. So again, since it's a constant, we do have to add that to our mean, our expected value. So we get 210 plus 25, which gives us an expected value of 235. All right, now our standard deviation of 3x plus 25. Okay, well, that's going to be equal to, we do have a scalar here, so we do need to multiply that. So our standard deviation is going to be equal to our scalar times our standard deviation of 11. So our new standard deviation is going to be 33. All right, now for part C, we're going to actually combine two different variables. So now we're looking for the expected value of our variable, both of our 2x minus y. Okay, so we have our random variable x and our random variable y in there. All right, well, our expected value, we do need to multiply. Sorry, let me go back, erase that. That's not what I wanted. All right, so that's going to be equal to our scalar, so 2 times 70, and then we're just going to subtract our expected value of y, which was 14, which gives us a total of 126. Okay, and now to find the standard deviation of 2 times our random variable x minus our random variable y. Okay, well, that's going to be equal to the square root of, all right, we have our random variable x squared. Okay, and then we're multiplying it by that scalar, and since we're multiplying it by a scalar, we're multiplying all of our random variable x by a scalar, we also have to square that guy as well. So it's going to be 2 squared times 11 squared. And then remember, even though it says subtraction in there, we always add them together. So it's going to be plus our standard deviation of our random variable y, which is 5 squared. And then we can calculate that guy out. So we end up with 4 times 121 plus 25, the square root of all that. And that gives us approximately 22.56. One of the big things in there is that you need to know that whenever we're multiplying by a scalar, so when we're multiplying by a scalar, that in our standard deviation, we need to square that scalar as well. Okay, and we'll do a couple examples, and you'll see that there's what happens when we don't need to. All right, so now we're going to go back to example 1. Okay, so if you haven't read the problem, please go ahead and do so now. All right, so if you read the problem, we find that for our insurance problem here, they tell us that we have a mean of 20 for a random variable and a standard deviation of 386.78. All right, and now it wants us to know the company decides to double all of the payouts. Okay, so doubling all of our payouts, so that means we're going to multiply our random variable by 2 since we're doubling it. So what's our new mean and standard deviation? Well, our new mean and standard deviation, so we're looking for the mean, which is going to be 2 times our random variable. So 2 times 20, should be a piece of cake. All right, and our standard deviation, if we're going to double all of our payouts, is going to be 2 times our standard deviation, which was $386.78, and that's going to give us $773.56. Okay, so now let's look at Part B. There's the big difference in Part B. So now we're looking at just 2 customers, Mr. X and Mrs. Y. Okay, what are the expected payouts on $20 on each policy? Okay, what is the expected payout, total payout for both customers and the standard deviation? Okay, so now we're not looking at just doubling all of our payouts, okay? Now we're looking at combining 2 random variables. We have Mr. X, that's one random variable, and we have Mrs. Y, so that's another random variable. So we're looking for now our expected payout of X1 plus X2, because we have 2 different people, 2 different individual people, so that's 2 different random variables. And again, if we go back to our concept chart, okay, we know that that's just the mean of one plus the mean, and when we combine our random variables, it's the mean of the other guy. So then we're looking at just adding those 2 together. So we know that our mean of Mr. X was 20 and our mean of Mrs. Y was 20, so that gives us a total of 40. Okay, and now for our standard deviation, so now we're looking at the standard deviation again of X1 plus X2, because they are the same. All right, they are 2. So we're going to have, that's going to be the square root of our standard deviation squared, so 386.78 squared. And remember, it doesn't matter if we add random variables or if we subtract random variables, we always add them together. And we get, so we're going to add, our second one was $386.78 squared. Okay. Which also we can rewrite that as just 2 times $386.78 squared, because we got 2 of them. And that's approximately equal to $546.99. Alright, so now for C. So now suppose we have 5 policyholders with an expected payout of $20 on each policy. What is the expected payout for all customers and standard deviation? So now we're looking for the expected payout of customer 1, okay, plus customer 2, customer 3, customer 4. So we can just write that. We're going to add all of them to customer 5. Okay. Well, we have 5 customers and they all have an expected payout of $20. So we can add 25 times, or we can just multiply it by 5, which gives us $100. And similarly, we can do the same thing with the standard deviation. Okay, so our standard deviation of X1 plus ... to our 5th customer, X5. That's going to be equal to the square root of, alright, so we have 5 different times, we're going $386.78, we're going to square it. Okay, since we're going to do that 5 times and add them all together, we can just multiply that by 5. Now keep in mind, this is 5 different random variables. We're not multiplying the payout by 5. Okay, we're not multiplying it by a scalar. We're just adding 5 different random variables, and so that's why we're not squaring the 5 as well. Okay, so we're just taking 5 and we're multiplying that times our standard deviation squared. So that's going to give us approximately $8,648.66 is going to be our standard deviation. Alright, sorry that I was looking at the wrong example there. It's actually going to be $864.87. Okay. Alright, I want you guys to go ahead and pause the video, and I want you to go ahead and do example 1D right now and see if your answers can match mine. So go ahead and pause the video. Alright, so go ahead and check your work. You should have gotten a mean of 10,000 and a standard deviation of $8,648.66. Okay, remember that each X1, X2, X500, those all represent different random variables for the different people, which are all different random variables for those insurance companies. Okay, so now we're done example 1 and example 2. Let's go ahead and go to example 3. Okay, and so we're looking at a local law firm that has a yearly average profit of $700,000 and a standard deviation of $60,000. All right, it owes a source of capital fee of $50,000 plus 5% of profits of the random variable x. Okay, they give us an equation there. They let us know what y equals. So, again, we're given that our mean of our random variable is $700,000. And our standard deviation of x is $60,000. And we're giving that y is equal to 0.95 times x minus 50,000. And they want us to find the new average and new standard deviation. Okay, so our new mean of our y variable is going to be equal to 0.95, we multiply it by the scalar, times 700,000. And then we are going to also subtract. It is a constant, so we're going to subtract that 50,000. And that's going to give us a new mean of $615,000. Okay, now our standard deviation. So our standard deviation of that random variable y is now, so do we add the constant? Remember, constants don't change our measures or location. So we're only going to multiply by our scalar 0.95 times 60,000, because that's our standard deviation, which gives us a total of our new standard deviation is $57,000. Okay, so now let's go to example 4. So a company is selling vegetable seeds in packets of 20, estimates that the mean number of seeds that will actually grow is 18, and the standard deviation of 1.2 seeds. So you buy 5 different seed packets. How many seeds do you expect to grow? Okay, so what is your average that you expect out of 5 packets? Alright, so I'm going to pause this. I want you guys to go ahead and answer all of example 4, A, B, C, and D. You should be able to do all of them and check your answers with mine. Go ahead and pause the video now. Alright, go ahead and check your answers. For A, if we have 5 packets of seeds, we would expect about 90 seeds to grow with a standard deviation of about 2.68 seeds. Our assumptions that we made about the seeds, the packets are independent of each other. Okay, and then if a farmer purchases 700, how many does he expect to actually grow? We would expect 12,600 seeds to grow with a standard deviation of 31.75 seeds. Alright, so now example 5, our last example for this video. Okay, the American Veterinary Association claims the annual cost of medical care for dogs averages $100 with a standard deviation of $30. And for cats, they average $120 with a standard deviation of $35. Assuming the animals are independent, what's the expected difference in the cost of medical care for dogs and cats? So we want dogs minus cats. What's the standard deviation of the difference? Okay, so first we want to make sure that we label our random variables. So we're going to go ahead and we're going to let X stand for dogs and Y stand for cats. Okay, we were given that dogs have an annual cost of medical care of $100 with a standard deviation for dogs of 30. And then for cats, we were given that they have, oops, that looks more like a Y. Or, I'm sorry, next. There we go. All right, they have an annual cost of $120 with a standard deviation of $35. Okay, and now the key word in that problem is difference. Okay, and what operation goes with difference gives us subtraction. So we're looking for our average cost if we were to subtract our two random variables. Okay, well, if we're looking to subtract them, we're looking for the difference. We know that our average of dogs was $100, and if we're trying to find the average of this difference, we're just going to subtract them. So 100 minus 120, which would give us negative $20. All right, and then now we're looking for the standard deviation. So our standard deviation of dogs minus cats is going to be equal to the square root of the standard deviation of our dogs. And again, it does not matter if we're subtracting or if we're adding. So we got 30 squared. We're going to add our standard deviation of cats, and we're going to calculate that out. And if you guys calculate that out, you should get a total of $46.10. So we have two different random variables. We had dogs and cats. All right. And if we were looking at the difference in medical care costs from dogs, cats from dogs, we would expect there to be an average of negative $20 in the difference with a standard deviation of $46.10. Okay, so that is all for this video. Tomorrow in school, I expect you guys you're going to get a little worksheet to kind of these same concepts to help you out. And then I want you guys to complete your homework, and then you know where that's at. That's on the pacing guide. Okay, you do have a Math Excel and a little bit of bookwork, and help each other out. Okay, and then there will be another video posted for the following day. Thank you.